So you were asked in the warm-up to figure out the volume of this solid. It has this as the one cross-section, and the cross-sections perpendicular to this plane are all circles. Hopefully you can tell that the shape that this is going to have, since this end is a circle and this end is going to be a teeny tiny circle, this is actually going to be a cone. And what we're going to do is we're going to take a look at one of these circles. Let's just give it a location here. Okay, here is the radius of one of those circles. And we're taking this cone, cutting it right here, and seeing that we have a circle that is the cross-section. So the cross-sectional area will be the area of that circle, which will just be pi r squared, if this right here is r, which means that the volume of just the disk, the circular disk, is going to be that cross-sectional area pi r squared times its thickness, which is dx. And it's x because we're cutting it along the x-axis. That's where this thickness is. We don't want to actually integrate, though, r squared dx. Those aren't the same variable. And the radius changes as x changes, so it is a function of x. So we need to find out what r is equal to. Well, we can write an equation for this line. We know the slope is going to be a over h for this cone. So y is equal to a over h times the location x along the length of this cone. And y is just equal to r. That's the height above the x-axis. So the volume of the disk is going to be equal to pi times a over h x squared. And so to find the total volume of this shape, we're going to integrate from x equals 0 to x equals h. One thing I want to point out is that the a, the h, and the pi are actually all constants. So we can just we can just pull those constants out of the integral. So that will be pi a squared over h squared times that original integral that we had. This is a fairly simple integral to evaluate, just using some of our formulas for a power rule. And now we need to evaluate this at 0 and h. So evaluating this at 0 is pretty simple because the whole thing's 0, so we really only need to evaluate it at h. And so once we have this, we can do a little bit of simplification and get that the answer, the final volume of this, is 1/3 pi a squared h. In other words, this is the area of the base, pi a squared, times 1/3, so 1/3 of that quantity times the height. And this is the formula that we know for the volume of a cone.